So for today, there is quite a few things that we need to learn, and I'm going to start it right off with adding a couple of functions together, but they're going to be fractions. So if you can't do this, then you wouldn't have a chance to be able to add two functions that were fractions with variables all over the place. So just add two fractions. This is, you'll see, is right off the top 20, and it's why we needed it, because today's function work. Nope, cell phone goes in the backpack. Nico, now? No, not in your pocket. It's going to go in your backpack now, because you just took it out and used it when you weren't supposed to. So, thank you. It's not that complicated. You were just turning it off? Yeah. That's wonderful. Then it doesn't need to be in your pocket. So put it in your backpack. I'm glad you were turning it off. Looked to me like to check the text, but that's why I don't know, and that's why it'd be best if it just goes in the backpack and nobody has to worry about it. All right, so you should have started by timesing by something on all the parts. So Nick, would you start with that? What did you times by on the either the left or the right side? Don't care. Which would be 6, and then what did you do?
I multiplied the 1 by 3, and then the other 1 by 2.
I think you mean this? Is that what you mean? Okay, and then you would end up with 3, 6 plus 2, 6, and that makes 5, 6. Raise your hand if you had that one exactly right. Okay, good. Now, what if they were much more complicated? What if it was two functions being added together, and one was 1 over x, and the other one's 1 over x plus 1? And you'd think you'd just do something fancy with that plus 1 and like somehow add 1 to the denominator on both sides, but there's no such thing. If I just add 1 to this denominator and add 1 to this, you add 1 to the top and the bottom of something, that doesn't keep it the same. You can't do that. You got to keep the same system, which is multiply the denominator. So go ahead and do that and add these together once you have a common denominator. In a moment, I'm going to ask you to share that with the kid next to you and see if you, the kid next to you, you two are going to work together too. See if you get the same thing as they did. And you're going to work with the kid behind you too, because he's working over there. It's super important that you learn how to get a common denominator. Okay, so you should have started. Oh wait, I didn't give you a chance to talk to your neighbor yet, but let's make sure that you were on the right track. Did you multiply by x plus 1 and x plus 1? The other denominator, and did you multiply by x and x? If you did, why don't you compare and see what you think the final answer was? So that part, x plus 1. This part, x. And there's a plus in between them, which made it a lot easier, believe it or not, over that, which I'm going to leave factored. I know a lot of you multiplied it out, you distributed that x in, but remember the old saying, if you can factor it, you should? Why should you? Why should you leave this factored like that? Because then you can see if something on the top will cancel with something on the bottom. All right, so I'm going to put this and this together, and I'll get a final answer of 2x plus 1. Over x times x plus 1. If you multiply the bottom out, you're not a bad person, but you missed the chance to maybe cancel something. So I think leaving it factored is smarter in this scenario. How many of you actually had it right? Okay, good. You didn't have to have it factored to have it right. But if you don't factor it, there's a chance you're going to miss a cancel with the top. Okay. So that's Adding two fractions. Let's divide two fractions. 1 over x over 1 over x plus 1. It's the same two functions. It's almost like I gave you two functions. This one's f of x and this one's g of x, and then I said to divide the two functions. Because that's what's going to happen today, is you're going to be given functions, and you'll divide them.
Does it matter?
Yes, it does. Always the second one.
Well, again, this is a top 20 thing. One of the reasons we have to know that this and this are two fractions and you just have to flip and multiply is because of moments like this. X plus 1 goes to the top. Notice it's flipping. And then the bottom one had a 1 on top, and now the 1's going to be on the bottom. And now I can just multiply across the top and across the bottom, and I get x plus 1 over x. That worked pretty good. By the way, what's the implied domain of that? What can't x be? 0. So that means it's all real numbers except 0. That would have been the domain of this. And you had a test on that just the other day. But wait, it's more complicated than you would think. Doesn't it just look like the only thing you have to worry about is that x can't be 0? And in the problems you just had in your last test, that would have been the right answer. But the domain on combined functions is more complicated than you would think. I'll tell you the rest of the story in a minute. So let's start with a simple one. Let's go to the slide. I think it's green. Let me see. It's, nope, pink. That one. Everybody go to that slide. Yes?
Could we not take the x's out of the answer?
You could not, because there was an x plus 1 on the top and just an x. So then the x's like that can't cancel. They are, it's like this. If I asked you, could I cancel these 5s, would you let me? Well, you tell me. What's 5 plus 1? 6 divided by 5. 6 fifths. Can I cancel those? No. So you can't cancel the other kind either, because it's part of an add problem. If I had this problem, could I cancel the 5s then? Yes. So it's about whether it's over addition or multiplication. If it's over multiply, you can cancel stuff like that. This one, no, you cannot cancel that. Okay, back to this. Combining functions. Here's x squared. Here's x plus 2. If I just add them together, it is as easy as you would think. That plus that. X squared plus x plus 2. The end. Super easy. Okay? It's the domains of these things that get complicated. But we'll deal with that in a minute. F times g. So we're just going to take this one times this one. Be careful, far more mistakes are made here. Okay, so F times G, I got to go this one times this, and then separately times that. Why? Well, you can't just times by the first part of it. I think you'll get that. You can't just take this times just the first part. That wouldn't make any sense. You got to distribute it. So it's x to the third, because that's x squared times x, plus 2x squared. Raise your hand if you had that one right. Okay, good. Most of you caught that. And last is f divided by g. F is x squared divided by the g, which is x plus 2. Can you cancel those x's or not? No, because this one's part of an add problem, so you cannot cancel those x's. And then that's it. Okay. Let's talk about domain again for a second. It's a super easy question, but a lot of people will be stumped. What's the domain of x squared? Well, you're used to seeing them when they're like this. And you'd be like, well, it can't be 5, and it can't be negative. Let me think. It can't be less than or equal to negative 4. Okay, but when they were just like this, what's the domain of it? All real numbers. Everything works. Nothing fails. Remember, domain is what you can put in. Do you get you can put in anything you want in x squared, and it won't cause a problem. So that's all reals. I'm giving you permission to write that from now on instead of saying negative infinity comma positive infinity with parentheses around them. That is a double barred R. That stands for all real numbers. Yes?
Could we also just write all real numbers?
You absolutely can. It's just a little faster to make the double R. You'll see. See, boom, done. It's fast. So I'm just trying to give you a shortcut. That's all real numbers also, because you can put in anything you want and it won't crash it. So what if they're more complicated? Well, then you figure out the domains, just like on our last test. But when you combine two functions, you have to combine their domains. All right, let's go look at that. Oh, wait, that's not this slide. I'm going to go off to the side and make one. Okay, everybody make this function. F of x equals 1 over x plus 3. And we'll say g of x equals the square root of x minus 4. First thing I want you to do is just, this one's easy, find me the domain of f. I'd put it on a number line, and I have a reason. Trust me, make a number line. Then figure out the dg. What do you think that means? Just take a wild guess. What do you think dg means? Domain of g. Okay. That's completely different than DJ, who like comes to your party and plays music. Okay. So what's the domain of f? Already said it. What's the domain? Well, I guess maybe I said it in my head. The domain of f, remember I said use a number line. I'm telling you, you're going to need to do that. So trust me. And it's negative 3 is the key number. And it can't be negative 3. Did you guys agree that it can't be negative 3, but everything else? Right? You just had a test on this. You can't forget that stuff over 3 days. How about domain of g? I like to pull this out, even though I might be able to do it in my head, and I go x minus 4 greater than or equal to 0, x greater than or equal to 4. Remember, we aren't looking for what it can't be, we're looking for what it can be. And I actually think I may have said it wrong earlier, so this is the first time I've written it, though. Here's where 4 is. Why did I put 4 over to the right? So that my two number lines can be looked over at the same time and try to figure out where they overlap. Do you remember the old intersect symbol? The question is, where does this intersect this? I like to go like this and go, oh, it's from 4 to infinity. But be careful with that 4. Is the 4 in the intersection of the two? No. So we put a parenthesis. There's my final answer. And you could have written that as a number line also, but the first two need to be number lines because you got to see where they overlap with each other. Yes?
Wait, why can't it be 4?
Yeah, why
It
can't
should be included. Because it's only 4.
Oh, wait. Nope. Just hold on. When we're dividing the two functions, which is I think what you're thinking about, Jada, and defending me, and I appreciate it, we will need to take out the 4, but not right now. So you're right. For right now, we need to include it because you're right, and therefore I just didn't graph it right. There we go. I was reading my own graph, but I graphed it wrong. So there. Now, it's from 4 to infinity. It's where they overlap.
Oh, yeah. I was thinking
Because you don't want it to be
was
0.
graphed the other way then because it wasn't both. It wasn't for both.
I'll show why in a moment it can't be 0, or sorry, it can't be 4 in a minute, but right now it still can be. Okay, so all we are doing is adding, subtracting, or multiplying these two functions, then that would have been the answer. The domain would be where the two domains overlap. So if I would have said, hey, add the two functions, f plus g, you would have been able to just add this plus this, and then the domain would have been this. If I said f minus g, same thing. You just take this minus this, And then your domain is that. F multiplied by G, same thing. F times G also works for that. But the one that's different that I was going to ahead of time and I shouldn't have yet is F divided by G of X. All right, I want to investigate that one a little further because that's the hard one. And we're in honors pre-calc, so we don't give you the easy ones too often on the tests. So here's one of the harder ones where you divide the two functions. First, I have 1 over x plus 3 divided by square root of x minus 4. The first challenge will be algebra. Can you simplify that? Hint, put this over 1. Because then it's a fraction over a fraction. And then we've practiced that on the top 20. That's why that top 20 is so important. Here it comes again, a basic skill that if you don't know how to handle fraction over fraction, you're cooked. So simplify that down. It's 1 over x plus 3 times, flip it, 1 over the square root of x minus 4. 1 times 1 is easy. It's just 1. Why would this x plus 3 times square root of x minus 4, why would I cry a little bit and mark that wrong? It needs parentheses, because do you get otherwise only the 3 will be being multiplied by the square root? I'm putting in some green parentheses right there. If it doesn't have those parentheses, it'd be wrong. Just like last time, it's algebra issues. These are critical. This is why kids that have a 19 or a 20 on the top 20 who are very good at being careful are fine in this class. And the kids who haven't got theirs up to a 19 or even an 18, at least like an 18, maybe even a 17 is probably close enough. But if you're still down in like the 13s, 12s, you're going to struggle on things like this. You won't be careful enough. So that parenthesis right there was critical. Okay, now that's my answer, but what's its domain? Okay, didn't you just say a second ago, server, that you could just take the two domains and see where they intersect? Yes, except when you divide them. When you divide them, you have one last thing to figure. Do you agree that when I put g on the bottom, the g function can no longer be 0? Was it illegal for g to be 0 before? No, the g function right here, it was fine for it to be 0 until now. Now this function can't be allowed to be 0 because it's on the bottom. So even though 0 would have been okay before, now we can't have 0. So we have a third number line to put into the mix. I'm going to put it right up here. Whenever you do a divide problem, you also have to figure that there's a domain for the bottom function. Cannot equal 0. I don't want to say d of g because you'd think only the domain of the g function matters. It's the bottom, whichever one's on the bottom. Because we could say f over g or g over f. Whichever function's on the bottom can't be 0. Bottom not equal to 0 is what that says. So, looking at this function that we just made right here, what are the things that would make the bottom 0? Martin.
X plus 3 equals 0.
Yep, and so x would equal what? And therefore x cannot equal what? Good, and what's the other thing x cannot equal? 4. So that is another number line. Whatever makes the g function, the bottom of your function 0. So I'm going to go up and put that. It can't be 3, empty spot. 3 would make it 0. Negative 3, sorry. And 4 would also be a problem. So it can't be 4. But it could be anything else. And it won't make the bottom 0 except for those two numbers. So now if I include that in my final answer, I'm going to erase this part here and say, now I have to look at all of that. Do you get that now my answer will be greater than 4? It can't be 4. Why can't it be 4? Because it'll make the bottom 0. So now it's parenthesis. For the divide problem, it's always a little more complicated, one extra layer. So my final answer for this question is, that's the dividing of the two functions after it's simplified, and its domain will be, can't be 4, but it can go to infinity. So x is greater than 4. Whew, that's a lot. Yes?
So then on a test, if it's asking for the domain of all of the problems, you have to include even the one problem. If only one problem has a smaller domain, you have to include that.
How about we just do one more problem, because I think that would be good. I'm not sure I understood how you asked that, but what I'm trying to get across is that when you're dividing the two functions, that's the hard one. To add them, easy. To subtract them, easy. Multiply them, easy. It's only when you divide two functions that you get this. So let's do that. Let's say this time f is going to be, f of x is going to be 1 over x. Super simple. G of x, square root of 2x minus 5. I'd like you to tell me, we'll do one of the easy ones. What's f minus g of x? And then tell me its domain. You want the domain of f. You want the domain of g. Is this the really tricky one? No. The really tricky one's divide. We can get this down. What I have taught you today is literally about a third of your next test. All just happened today. You got to add functions, you got to subtract them, you got to multiply them, you got to divide them. You got to find the domains of all of those things. And you have to do this little thing called the difference quotient, which we had on our last test, except we just have to add one more little tiny thing to it. All I'm trying to say is, this is hard. I know, there's a lot to it. But it's a lot like what you just did in the last unit. Five halves is 2.5. I hope you can forgive me for changing it to a decimal. I just felt like it. And then it's greater or equal to. Remember, strong advice. Make number lines for these. Because I know where you're going, and it's going to get tricky. You'll have 3 number lines when we're all done. Did you get your domains done for f and g? Because we'll need those. All right, so now we just have to subtract the two functions. Here's the first function, 1 over x. I'll use green for the second function, minus the square root of 2x plus minus 5. And can you put those together? Could we make them have a common denominator? Yeah, you can add any two things and get a common denominator. But this one's going to be a little weird. Would you agree I can put it over 1, and I haven't really changed it, but now at least I can see its denominator? Then would you agree I can times it by x on the top and the bottom? And now they have a common denominator. So then you can put it together and say 1 minus x root 2x minus 5 all over x. that is harder because of the whole common denominator thing, but that is what f minus g of x is. And what's its domain? Well, once you make the other two domains, it's really easy. See? It's 2.5 and bigger. They both have 2.5 in them, right? So it's 2.5 or bigger. So I could just write 2.5 included to infinity. If this had been the divide case, we would have added in a third number line. But do you get that for the subtract case, f minus g, we just had to get a common denominator for these two and see where their domains intersected. Does that make sense? Raise your hand if you feel okay with that so far. Okay, good. Then I'm going to add one of those divide problems. I'm going to make it above it. I want you to try to figure out what f of x over g of x is. You can abbreviate this as f over g of x. Don't overthink this. You're just dividing them. It's actually easier. But the domain has a third number line. Pause for a second. Okay. So now I've got f of x, which is this one, over g of x, which is this one. And I can put this over 1. And then remember the deal. If you've got a fraction over a fraction, I got my blue fraction and I got my red fraction, I can flip and multiply them. So it's 1 over x times, flipping it, 1 over root 2x minus 5. One times 1 is 1. X times the square root of 2x minus 5. Some kids think they're doing a good thing to distribute that in. You cannot do that. It wouldn't work. The way I can prove it to you is take little numbers. If I said 2 times the square root of 2 plus 8, that'd be like 2 times the square root of 10. Can you distribute this out? You might think you can, but you can't. It'll be a completely different answer. That would not work. No such thing. Okay, so there's my answer, and I need a third number line. I already have these two number lines, but I need a third one. To find the domain, I have to also include a number line that's for what would make the denominator 0. So in this case, that is the g function. So I'm going to say g cannot be 0. What would make the bottom 0? If x was 0 or if x was 2.5. Either one. Can't be 0. Can't be 2.5. And now if I extend this blue up and include this last part, now the only thing that overlaps, the only thing that really changes is the 2.5 isn't allowed anymore. 2.5 to infinity was your domain. Heavy duty stuff. Yes?
So far, there's been a pattern sort of where when you originally get that, like for instance, the square root ones that it's greater than or equal to, but then if it's divided by, you go back and like.
The danger to what you're about to ask me is, will it always be like that? And the answer is no. Because if you flip-flop it around, do you get that function would be on the bottom? And if that function's on the bottom, it's much harder to figure out what would make that function 0, because that function can't be made equal to 0. Think about this for a second. If the f function had been on the bottom, do you get there's no way to make 1 over x into 0? There's no way to make 1 over x equal 0. You can't do it. No matter what you put in for x, you can't make it equal 0. So therefore, if this had been on the bottom, the domain actually wouldn't have changed at all. So you're not always going to take the number that was greater than or equal to and remove the equal to? No.
If it's always a square root one on the bottom, though,
Yes.
can you do it
Yes. If it's a square root on the bottom, then that would work.
every time that there's a square root?
Yes, unless there's also something else besides the square root. This is why alwayses and nevers don't work out too often, because yes, if it's just like that, it'll be just like that, but it has to be just like that. You should quote me on that one. Anyway, okay, so moral of the story. If you have three, if you get 3 number lines, it's probably because you just did a divide functions problem and you had to find the domain of it. That was super intense. Now the good news is the rest of it's easy. Okay, so all I got to do is get you through things like this. Do you remember this from the test, except it didn't have the h? Remember me telling you ahead of time that eventually we would divide by h? I did mention that before. You might not have caught it, but... So now it's the same exact thing as you just did on the test, except you have to also divide by h. All right, let's try one of those. Everybody try this, 4 minus 5x. So you go 4 minus 5, and instead of x, you put in x plus h. And then you subtract f of x. Well, we know what f of x is. It's y. And whenever you have a variable, you should put parentheses around it. So minus f of x, that's the part I'm doing right now. And that's our f of x. So 4 minus 5x. But it's all over h. That's new. If you didn't notice this before, most of our problems had an h in them at the end. This just, you'll have to just factor it out and cancel it, that's all. Four minus 5x minus 5h minus 4 plus 5x all over h. Look for things to cancel. Plus 5x minus 5x minus 4 plus 4. Holy cow! It's all came down to this. Negative 5h, but there's another h, so they cancel. So it's negative 5. Now, some of you aren't going to care about this little extension, but some of you will. If I had just said y was equal to negative 5x plus 4, do you get that I just found the slope of that line? The answer was negative 5. Coincidence? No. Because technically, this thing called the difference quotient would find the slope in a much more complicated way, because it also works for curves. Can you imagine if, when you learned how to find slope in like 6th grade, if they'd have taught you this instead? People's brains would have melted. So, but it's true. It's just the slope formula in a much more complicated way that also works for functions that curve. How can you find the slope of something that curves? Well, you'd have to pick a starting spot and then move over some distance h and then put a dot there. Do you get that if I move over just the right distance, this will have a slope of 0 actually? All depends on where you start and how far over you move. The one we just did, why was that so simple? Because it was a straight line. If you graph that, it's a straight line. Therefore, it has a constant slope that's always negative 5. Done. Easy. But what's the slope of this one? Well, it depends. It depends on the x, which is where you start, and the h, which is how far over you move. So I might know that that's a parabola. And I also might know that its y-intercept is where x equals 0, and so it must go through 0, 0. So let's say I think it looks like this, and I want to know its slope. Well, you use that function we just did. It's called the difference quotient. Everybody please do the difference quotient on this one. f of x plus h minus f of x all over h. You'll find that the slope isn't just 2. Wish it was that easy. But the slope depends on x, which is where it starts, and h, which is how far over you move. So your answer will have an x and an h in it. This is the careful test again. So if you had trouble with those, which I know some kids, that's the only problems they got wrong on the test, was the easy one like this and then the harder one like this. So these are hard, I know. But you can't afford to let this go, because it's a skill that's going to come up again and again and again, is evaluating functions. Pausing. So I'm going to stick x plus h into this function here and here. And then I have to subtract f of x now. Parentheses for my f of x so that I don't only subtract the first term. All over h. I'm going to do a 1, 2, skip a few. This is going to be 2x squared plus 2 times 4xh plus h squared, and then I times it by 2, 2h squared. And then I'm doing this next part in blue, plus 4x plus 4h. I'll do the last part in black again, minus 2x squared minus 4x. That little minus right there is the most missed thing. For some reason, when people distribute a negative, they don't catch the second one. Then, all over h, but wait, I have to cancel some stuff first. I'm looking for things that are identical but opposite, so look at that. That cancels that. That cancels that. And now I've got that, and it's all divided by h. Now, I'm going to factor out the h in my head from the top, and I will get 4x, because see, I factored out the h, and then plus 2h, because I factored out an h to the front, plus 4, because I factored the h out to the front, all over h, and then the h's cancel, and there's the answer, 4x plus 2h plus 4. Do you get it? Depends on x, and it depends on h, because it depends on where you start on the curve and how far over you go. That'll be what the slope is. Yes?
When we get an answer like that, do you want us to leave it like that or factor out the 2?
Leave it exactly like that. I do say if you can factor it, you should, but that's only really going to be helpful if there's a denominator where something can cancel. So if there's nothing to cancel, you don't have to factor it. But I love it when kids factor it, because then I'm like, ooh, that's an extra smart kid. They know that it can factor, and I never mark it wrong for just factoring it. Okay. There we go. You've made it. Now this is just a word problem, which is like piecewise function again. It just happens to do with costs and profits and stuff. We're going to gloss over that because it's not as important. And there's the homework, but I don't recommend you doing this homework because I made a Schoology quiz version of it, which is much more straightforward, far less questions, and you can begin that immediately. That's your homework for tonight. And that's all I have for the video for today.